Alright guys, let's let me get out of this. That was weird. And these are two screen captures that did not work. And I can't delete them, which is fine. Okay, I am sorry. I'm gonna put you on pause. Alright guys, sorry about that. So sorry about class today. And I am going to try to go as fast as I can while covering all the material needed. So first let's talk about function header. Function header always has the word function followed by two brackets and the function name and two input arguments. These are the input arguments, and inside here would be the output arguments. Let's follow off of Peralta's thing. Function header. This whole entire thing is considered the function header. Word function, the output arguments, function's name, and then the input arguments. Be sure to mention the difference between these and the input command. Guys, do not use input command. You guys remember input, whatever number you want. Don't use that. This is our input right here. So let's just make one up. I'm going to use my function name to be fn. I'm going to have one output, and I'm going to have two inputs. And I'm going to say that x is equal to y plus x. Now this is legal because I'm just redefining x right here. I still use the input x right here, and the output is defined as x. If that's confusing for you, I could say nx. And this is a super simple function. We'll run it. We'll call it fn. We'll dock it. And we'll say that fn of 3 and 4. So they add them together, and our answer should be 7. Now, if you see that nx, I did not suppress it. He wants me to show you what happens when I do suppress it. I'm going to suppress it. I'm going to save it. I'm going to do the same. And you see that only one answer pops up. It's important to note that this nx, that is a local variable. It's not global. It won't show up here in my workspace. And just to show you, let me open my workspace. And I will clear everything. And then I'll run fn of 3 4. 3 plus 4 is 7. And you see that our workspace A and S pops up. That's our default variable, but nx does not. That's considered local to this function that we named fn, or just fn. The return command at the end of the function can use end. Guys, always use return to end the function. You don't necessarily have to use return, but it's good practice. Let's do that. So let's go over what we learned. Function header. This was a typical function header. This is how I want you guys to write all your function headers. We're always going to open an editor, and the first word is going to be function, followed by the outputs, set equal to the name, and then your input. Directly under that, we do have this option. This is the help option, and right here we put what our function does. Here I just said it's a help option. But if I go over here and say help space fn, you'll see that it's a help option. If you didn't know the help function, I would look that up. It helps you with all the functions that you're not sure about, like cosine. help cosine. It gives me a whole list of cosine. I also want you to cover the find function. It allows the users to search through a matrix to find values given a condition. We'll now just go over these operators, the conditional operators to use find. So let's get away from functions for a second and let's just go straight to find function and undock this. Clear it. Let's create a matrix that's equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. If I say find where x is equal to 5, it will give me the position that 5 is in. Here 5 is in position 2, so I'm expecting the value a and s equals 2. That's true. Find where x is less than or greater than 5. I'm expecting 6, 10, 7, 11, 8, and 12, those positions. I don't know them off the top of my head. We can count them though. 5, 6, 8, 9, and 11, and 12. Oh, and 3. Oh, I didn't say 3. Oh yeah, 9. Sorry. So this is the find function. You guys have the option of carrying an equal sign here, and it'll just include where 5 is at. You have an option of listing just the first 3 variables, so instead of sending 2, 3, 4, 5, 2, 3, 5, 6, 8, 9, 11, and 12 position, you're just going to get the first 3, which is 2, 3, and 5, or the first 8, which is all of them, the first 5. You get the picture. We're just flying through this. Do 6.3 and 6.4 in MATLAB, and I do not have it opened up. So I'm going to come over here, open up my MATLAB book that I sent everybody. Y'all should have this. And I'm going to go to, I don't know what page it's on. I'm going to guess 300-ish. See what 300, chapter 8. It's not 300-ish. 250-ish? Yeah, 256. And we're going to do problem 6.3 and 6.4. So here's problem 6. Let's open up MATLAB on that side. This is weird. That's not how I like my layout. That's how I like my layout. We're going to open the editor, and we're going to shift everything. I'm going to undock that. I'm going to start on 6.3 right here. If everybody wants to follow along, let's read it first. The future value of money formula relates how much current investment will be worth in the future, assuming the constant interest rate FV is equal to PV times 1 plus I to the nth power, where F of V is the future value, PV is the present value, I is the interest rate expressed as a fractional amount per compounding period, i.e. 5% is going to be 0.05, n is the number of compounding periods. Create a MATLAB function called future value. So let's write our function header. Function output variables is equal to, they want me to name it future value, and these are my input variables with 3 inputs. Okay, the investment, present value, the interest rate expressed as a fraction, and the number of compounding periods. So I'm going to use PV for present value of investment. I'm going to use the interest rate expressed as a fraction, which was I, and then I will use the number of compounding periods, which they just called capital N. And I'm going to write a little note to myself. Future value of money formula. Now I'm ready to start coding. In which case I just say FV is equal to PV times 1 plus I to the n. Now I'm just going to throw a dot everywhere because I don't know, just in case. You guys don't really have to do that, but if they want to send me 3 different values for each one, I want to be able to calculate that. And then I'm going to say return. And here my output is going to be FB. And I don't know why they're giving me this as an error. That's weird. And that's it, guys. That's what they wanted from us. So we'll run it, save it as future value, say yes, dock this, CLC and clear this, and then they want me to use the values of 100, or I'm sorry, 1,000 for the initial investment. They want 10 years, compounded monthly, so that's going to be 10 times 12. There's 12 months in a year. And then, oh, I forgot one number because they went out of order. And they want the interest rate to be 0.5%, which is 0.05. The reason I put that in the middle is because over here you can see that our first place is reserved for the present value, our second place is reserved for the interest rate, and our last place is reserved for the number of compounding periods. So I press this and I get 2 answers, both of them the same, and that is because I didn't suppress this output variable. I want to dock that and suppress this. So dock, okay, dock. Let's do it one more time, and this time I'm going to say that future value is equal to future value. Not enough input arguments. What did I do wrong? Oh, there we go. And say that future value is equal to, and I should undock this, 10 times blah blah blah, and I get the future value. Okay, that was 6.3. Let's do 6.4. So I'm gonna dock this and open up another editor and undock that and get started. In freshman chemistry, the relationship between moles and mass is introduced. Oh, I did not study up on this. Uh-oh. N is equal to m divided by mw. That's true. The mass of the substance divided by the molecular weight, or the molar mass of the substance, is the number of moles. That's true. I believe that. So let's start off with our function header. We'll just leave everything blank until we know what to write. Creating an M file called nmoles. So they want nmoles to be written here. That require 2 vector inputs. Whoa. Okay. 2 vector inputs. The mass and the molecular weight. They use lowercase m and uppercase mw for mass and molecular weight. Mine will be the same. Because you are providing vector input, it will be necessary to use mesh-grid function in your calculations. Well, let's get that out of the way right now. We're going to say new m, comma, new mw is equal to, oh, I'm sorry. Nope. There we go. There we go. That's how you use mesh-grid. Mesh-grid of m, comma, w. And now we can find what n is equal to. N is equal to m dot divided by mw. Remember, I put an n right in front of all my new vectors. And that looks like it's it. Return. And I'm going to run it. And I'm going to save it as nmoles. Yes, I want to replace it. And I'm going to dock it, CLC it here, and I'm going to go to part B. Test your function for the compound shown in the following table for masses from 1 to 10 grams. For benzene, ethyl alcohol, refrigerated R134A. I'm not even going to try to. I'll try it. Tetrafluoroethane. That sounds right. So let me undock this to show you what I'm going to write. I'm assuming that they want us to go from 1 to 10, counting by ones. So I'm going to say n moles. First I'm going to say n is equal to n moles. Hold on, did I? Uh-oh. I messed up. Control undock. I did not put an output. And I want to suppress these. Alright, now I'm ready to go. N moles of 1 through 10, comma, and I'm going to put these values in for the molecular weight. It's 78.115, 46.07, and 102.3. Sounds like that would be a rock station. I don't know why, but I feel like that to be true. Now I hit enter, and you see that it gives me all the possible combinations of these. Well, guys, that is all. Your result should be a 10 by 3. That's good, because I have 3 rows and there are 10 columns. That's correct. Perfect. Alright, that is it for this lab. Thank you for watching, and I will see you guys next Monday.